हेलो एवरीवन, वेरी गुड आफ्टरनून आप सभी को। तो दिस इज अनदर इंटरव्यू सेशन इन द सीरीज ऑफ पार्क एंड एनपीसीआईएल इंटरव्यू. In the panel, I have with me Ankush Gupta sir,
Thank you, sir.
and the student we have is Vivek.
Thank you, sir.
So Vivek, what are the preference subjects for you, and for which PSU you are giving the interview?
My preference subjects are heat transfer, mass transfer, FM, and IPC, sir. I am giving interview for NPCIL, sir.
Okay, good, good, good. So विवेक स्टार्ट करते हैं हीट ट्रांसफर के साथ. ठीक है.
Yes.
What are the different modes of heat transfer?
There are three types of modes which are involved in the heat transfer, which are conduction, convection, and radiation. Convection, sir.
So in the case of convection, we study the concept of bulk motion.
Yes, sir.
We study the concept of medium movement.
Yes, sir.
How many types of convections are there?
Two types of convections are there, sir. Convective heat transfer and bulk motion heat transfer, sir. In convective heat transfer, where particle is moving, whereas the medium is stagnant, sir. Whereas in coming to the bulk motion heat transfer, in which particle and medium both are moving, sir.
I'm talking about the types of convection that we studied, like in terms of forced and free.
Forced and free. Okay, sir.
So explain that.
In forced convection, external agency like such as fan are used to create create a current, sir. Whereas in free convection, the currents are generated due to the temperature difference created naturally, sir. The buoyancy forces are created due to the temperature differences arised, sir. In free convection,
example of the natural convection.
Sir. Example of the natural convection: when a hot plate is placed on a floor on which cold air is coming to the contact with the near to the hot plate, sir. Instantaneously it will heat and its density gets decreases, and as and when its density get decreases, it gets up.
Wait. Is there any park near you? Any park?
No, sir. No, sir.
Okay. Have you went to the park?
Yes,
in
sir.
your life? Okay.
Yes, sir.
You are sitting on the table on the park, and
Yes,
some
sir.
cool breeze coming, and you felt very happy. Have you felt that?
Yes, sir.
Is this heat transfer? So is it a convection, conduction, radiation? What type?
Convection heat transfer, sir, I think.
Forced or free?
What, sir?
Forced or free?
Based upon its velocity, free convection, sir.
Free convection. No?
I
So
think.
that is what I'm asking, the example of the free convection. You
Yes,
can
sir.
simply say that in this world, air is moving here and there.
Yes, sir.
So whenever this air comes in contact with any hot or cold subject, it does the heat transfer. No?
Yes, sir.
Putting the hot plate on the floor, then the hot plate. Why to make it so complex? Okay. Explain the concept behind it, behind the natural convection, how actually the heat transfer takes place. First what happens, then what happens, then what happens, like this.
Initially, the colder air contact with the hot surface, which is having a more density, sir.
Ankur sir, एक बार आप continue करना, please.
Yes, sir. This more density compounds gets decreases its density due to the increase of the temperature. It gets over to the top of the surface, and then the cold air comes again contact to the hot surface. This hot surface is hot currents are created. Cold currents that are cooled by giving their heat to the hot surfaces, and then they are cool down. After that, they are getting more density. They fall onto the hot surface, and then they continuously do this process. This process is not a free convection, sir.
Okay. Can you
This is
tell us?
happened due to buoyancy forces difference.
Can you tell us any real life example of free convection?
Yes, sir. When we sit on a bench or in a hall, when summer.
Apart from that,
Apart from that, sir. I didn't get it, sir. As of now,
okay, no issue. So suppose if a person is having a sweat,
yes, sir.
so what happens? What heat transfers are involved there, and explain.
Or couldn't get it, sir. Explain it.
If a person is getting a sweat,
Yes, sir.
so and air wind is there,
Yes,
he
sir.
feels some cool breezes. We feel cool.
Yes, sir.
So why so? And what are the heat transfer what are the modes of heat transfer involved in this scenario?
I think 3 modes are involved, sir. All the 3. But the radiation is conduction, convection, and radiation, sir. But convection is radiation is a very less amount, sir, as compared to both the 2 operations, sir. 2 modes, sir.
So which is in large amount?
I think convection, sir.
So that's what I asked. Explain. If a person having a sweat and air is moving, so he feels cool. Correct?
Yes, sir.
So that which mode of heat transfer is there? You said all the 3.
All the
and
3,
radiation is in very small amount, convection is in large amount. So how heat transfer is happening? What is the mechanism? That's what I want to know.
Here, convective currents what travel in air and contact with the sweat, and then it cools the surface, sir. So we
Which
feel
surface? I'm talking about the human body.
sweat liquid, sweat, sir. Sweat on the body.
Okay.
So we feel cool, sir. These cold breezes contact in a hot surface of our body, and then suddenly they will condense, sir, on our body.
That is my question. If we are having a sweat, and suppose hot air is also moving in hot summer days, still we feel cool.
I think not so, sir.
You
we
can
can't
try
feel
someday. Okay. Have you played cricket or any outdoor sports in summer days?
Yes, sir.
So sweat come.
Yes, sir, comes.
And then if there is any flow of air, movement of air, you feel little cool.
Yes, sir. We will feel little cool.
Why? That is what I'm asking. If the air is hot, still we feel cool. Why?
Don't know, sir.
Do you know about the cooling towers?
Yes, sir.
What is the working principle of cooling towers?
Liquid is sprayed from the top of the cooling tower, sir, and air is passed from the bottom of the cooling tower, so that the heat is transferred to the heat from the hot liquid is transferred to the air, and an air is coming out of the top of the cooling tower, sir. In this way, heat is transferred from hot liquid to the gas, sir, in the form of convection process, convective heat transfer process.
Heat transfer takes place from a hot liquid to hot water to gas.
Yes, sir. Air. Yes.
In which cooling tower it happens?
Natural draft cooling.
Where you have studied this? That heat transfer takes place from hot water to air.
As of now, I didn't study it, sir. Only I have idea about how the
So why you have such idea that air heat transfer from hot liquid to gas?
Sir?
You said this is your idea that heat is transferring from hot water to air.
Yes, sir.
So my question is, why you are having such idea?
I think in nuclear reactors, after the steam generation, I thought I saw the videos, sir. I animated videos in YouTube. I thought so. Sir.
It is from any IIT
No, sir.
or any reputed university?
No, sir.
Then you can trust on any video on YouTube. In videos, they also show that the person is falling from 100th floor, still nothing is happening to that person. Anyways, have you heard a term like evaporative cooling?
Evaporative cooling, sir. No, sir.
Okay, very well. Do you know about the wet bulb temperature?
Yes, sir.
So can you explain the concept of wet bulb temperature?
Wet bulb temperature is the temperature of the air measured when the bulb is surrounded with the wick or having a water or liquid around it. It is saturated with the liquid. At that time, the temperature measured is known as wet bulb temperature, sir.
Temperature of air.
So
So
temperature.
Why that
Vapor gas mixture.
why that wet bulb temperature is coming there? That is my question. Because if
Wet
the
bulb-
bulb is dry, the temperature measured is dry bulb temperature.
Yes,
Now
sir.
it is wet. So the temperature of air is wet bulb temperature, which is less than the dry bulb temperature, correct?
Dry bulb temperature, sir.
That means the temperature of air is getting reduced.
Yes, sir.
That is my question. How it is happening? This
It is
mechanism. Can you
it is happening.
explain
Yes, sir.
step by step?
It is happening due to the vapor which is having a more heat. More heat. It loses its latent heat of vaporization and then it cools down, sir, due to the liquid which is contact to the vapor. So that due to the loss of the heat, the temperature that is measured is less than the dry bulb temperature, sir, here.
Air is losing the heat. Why?
And due to the liquid which is contact nearby to it, sir.
So if air is losing the heat due to the liquid, so why liquid is gaining the heat from air?
Because there is driving force difference, a temperature difference, I think.
Okay, no issues. So, which do you have studied multiple effect evaporators?
Yes, sir.
Can you tell me the difference between parallel feed arrangement and mixed feed arrangement?
Mixed feed, sir.
Yeah.
In parallel feed evaporators, the pressure from the first tank to first evaporator, first effect to the last effect is increasing, and temperature is also increasing in first effect to last effect. In mixed evaporator is also same, but in forward feed evaporator, we feed the
I'm not asking about forward feed. I'm asking about the parallel feed and mixed feed.
parallel feed. In parallel feed evaporators, we feed the feed into from the first effect and steam in also to the first effect. Whereas in mixed feed, we can change their positions according to the need.
Suppose I have three multi-effect evaporators. Three
sir.
effects are there. Can you draw the proper diagram, including
sir.
the steam and condensate?
Parallel, sir, first.
Yeah, first do it for parallel. Just a minute. Feed, steam, vapor, feed, steam, vapor, feed. So you are sending feed to the first effect?
Yes, sir. In parallel feed.
And the feed for second effect is coming from
first effect, sir.
So what is forward feed in there now? If it is parallel, then what is forward feed?
I think parallel is also there, same, parallel and forward.
Parallel feed and forward feed are same. And you said that pressure is also increasing in all the effects subsequently. The first effect, then second effect, pressure and temperature are more, and third effect, pressure, temperature are more.
Sir, I heard only 3 of the effects as of now, evaporators types.
Doesn't matter.
Forward feed, backward feed, and mixed feed.
Mechanism will remain same.
Yes, sir.
Sir, do you have to say anything on this?
कोई बात नहीं सर, स्टार्ट करते हैं सर, है ना। कुछ मैं मास का पूछना चाह रहा हूँ एक्चुअली, तो मास का कंटिन्यू कर सकते हो हमको सर?
यस सर।
चलिए ठीक है, तो विवेक मास ट्रांसफर से बात करते हैं। मास ट्रांसफर में मुझे बताइए कि व्हाट इज द बेसिक लॉ that defines the equilibrium in the distillation?
Sir, I think Raoult's law, sir.
Why are you saying I think in the answer of every question?
Maybe I am not having more knowledge. That's why I'm saying this.
If you say I think in every question answer, so it would be difficult for me to select you. So remove this word I think and then answer.
Yes, sir.
Repeat.
Raoult's law.
What is the Raoult's law? Okay. Define Raoult's law.
Raoult's law is equal to, Raoult's law is defined as a partial pressure is directly proportional to mole fraction of the same component in the liquid phase, sir, when they are in equilibrium with the, which is both of them are in vapor and liquid phases, sir.
Partial pressure किस component का किस चीज में?
Partial pressure of the component A in the gas phase is equilibrium with the component of the liquid phase, sir.
But
same component.
Distillation में तो कोई gas phase नहीं होता। आपने बोला partial pressure of component A in the gas phase, but distillation में तो कोई gas phase नहीं होता।
Distillation.
So are you sure it is partial pressure of component A in the gas phase? Raoult's law is applicable for gas liquid system?
No. Raoult's law is applicable for the vapor and vapor liquid systems, sir. Really equilibrium.
Really, no? Then why
Yes,
you
sir.
said partial pressure of component A in the gas
phase?
You should correct it, na? You should
Yes, sir.
edit it. So
Yes, sir.
edit it and then again repeat.
Partial pressure of the component A in the vapor phase is in equilibrium with the partial component in the liquid phase, sir.
Is in equilibrium with, उसके बाद आपने फिर गड़बड़ कर दिया। Partial component liquid क्या बोल रहे हो? Repeat again.
Partial pressure of the component A in the vapor phase is in equilibrium with the liquid phase of the same component, sir.
Is in the equilibrium with the
same
liquid
component
phase.
in the liquid phase.
Same component क्या? What is मतलब same component का क्या? Mass, pressure, concentration, क्या चीज?
Concentration, sir.
तो बोलो ना फिर कौन सा? तुम कह रहे हो in equilibrium with the same component. Same component का क्या? वो बोलो ना। लिख के दिखाओ, राउट्स लिख के दिखाओ, बड़ा बड़ा लिख के दिखाओ राउट्स अपने नोट्स में।
Yes, sir.
PA is equals to PAV into XA.
Yes, sir.
नीचे वाला छोड़ो, ऊपर wala. PA is equal to PAV into XA. Okay.
Yes,
So
sir.
what is XA? XA is concentration of a
Concentration of the component A in the liquid phase, sir. Of the component A in the liquid phase.
XA is the concentration of component A in the liquid.
No, sir. Vapor pressure that is acting by the component, sir.
What is XA? XA.
Composition of the component A in the liquid phase, sir. I think.
Composition. So
Mole fraction.
what symbol?
Mole fraction.
What mole fraction? Finally, why there is a so much delay? Even if you are unable to recognize the mole fraction. Sometimes you are saying concentration. Sometimes you are saying same component.
Sorry, sir.
It's mole fraction, na?
Mole fractions.
Now repeat the Raoult's law.
Partial pressure exerted by the component A in the vapor phase is in equilibrium with the mole fraction of the component A in the liquid phase, sir.
Okay. Okay. Now in this definition, remove this word is in equilibrium with. It's not in equilibrium. It's directly proportional.
Yes, sir.
That's why we have PAV there, means vapor pressure term there. That is a proportionality constant. So basically it's directly proportional. It's not in equilibrium. Partial pressure is itself equilibrium partial pressure. Generally we write PA star. So that equilibrium is there with the partial pressure. But it's not right like this ki both are in equilibrium. Okay. So now repeat again.
Partial pressure of the component A in the vapor phase is in equilibrium with the directly proportional to the mole fraction of the component A in the liquid phase, sir.
That is the exact definition. Okay. Now in this definition, just use one more word, which is equilibrium. Okay.
And
So
they are in
equilibrium
equilibrium.
partial pressure of the component A in the given vapor phase is directly proportional to the mole fraction of
Mole
the
fraction
same
of the
component in the liquid
in the
phase.
liquid phase.
Okay. Still the definition is not complete. We have a proportionality constant, which is vapor pressure.
Yes, sir.
On what parameter the vapor pressure depends?
Temperature, sir.
Temperature. So means if temperature
At
varying, vapor
constant
pressure varies.
temperature. Yes, sir.
Exactly. So equilibrium partial pressure of the component A in the vapor phase is directly proportional to the mole fraction of the same component in the liquid phase at a given temperature.
Yes, sir.
Okay. एक definition बताने में इतना challenge. Vivek. Okay. What is the law we use to define equilibrium in absorption? Name, I'm just asking the name. You don't know the name?
Don't mess.
Let me help you. Henry's law.
Yes.
You heard about Henry's law?
Yes, sir.
You studied absorption?
Yes, sir. Studied absorption, sir.
So you must have heard about the Henry's law. You must have used the Henry's law for solving the numericals also.
Yes.
Okay. Define Henry's law.
Sir, exactly, I don't know how to define, sir.
You know the expression?
Yes, sir.
Write it down.
P star is equal to H into XA, sir.
Show me. PA is equals to H into XA. That is not the basic form of Henry's law. That is wrong. Henry's law connect partial pressure with the concentration, not with the mole fraction.
Yes, sir.
So write it down again.
Yes, sir.
Now show me. PA is equals to HCA. Good. And PA, put star over PA.
Yes, sir.
Okay. So what is PA star?
Equilibrium partial pressure, sir.
Equilibrium partial pressure of
Component A, sir.
in
In gas phase, the vapor phase, gas phase,
gas phase. It's
Gas
absorption.
phase.
Na? It's gas
absorption,
phase.
sir. Gas
Good.
phase.
What is H?
Henry's constant, sir.
And a proportionality constant. है ना?
Yes, sir.
What is CA
Concentration of component A, sir.
in the?
In the liquid phase, sir.
Okay. Now define. Very easy. Just combine these three.
Equilibrium partial pressure of component A in the gas phase is directly proportional to the concentration of the component A in the liquid phase, sir.
For a
For a component A, sir.
given temperature.
For a given temperature.
Temperature is also there, na? And in the case of absorption, Henry's law is applicable. But there is one condition on which the Henry's law is applicable. You know that condition?
Dilute solutions.
Exactly. So when you start the definition, you will start like this. In the case of dilute solutions, comma, the equilibrium partial pressure exerted by the component A in the gaseous mixture is directly proportional to the concentration of the same component in the liquid for a given temperature. That becomes Henry's law. Very easy.
Yes.
Okay, good. Okay, tell me the law that defines the equilibrium in case of adsorption.
Langmuir's isotherm, sir.
Langmuir adsorption isotherm.
Isotherm.
You can write down the expression for that.
Yes, sir.
Write it down.
Yes.
X by m is equals to k p to the power 1 by n. This is Langmuir or Freundlich?
Langmuir.
This is not Langmuir. You heard about Freundlich adsorption isotherm?
Yes, sir. Yes.
This is Freundlich. Q by Q m. Yeah, sure. Q by Q m a is equals to k pa divided by 1 plus k pa. Okay, good. So on the left hand side, what is the term in the numerator?
Q, sir. Q.
What is Q?
Mass fraction of the
It's not mass
solute to the adsorbent.
No, there is no mass fraction. Q is not mass fraction.
Sorry, sir. I didn't remember.
Okay, no issue. Define relative humidity.
Relative humidity is the humidity. Is the ratio of the humidity mass of the water vapor at the actual relative humidity is the ratio of actual mass transfer to the mass of the vapor to the mass of the water to the mass of the water which is at saturation.
क्या बोल रहे हो यार?
H by HS.
What is your full name?
H by HS is relative humidity or percent saturation?
Percentage humidity.
What I asked?
Relative humidity, sir.
So why you are telling me percent humidity? I'm asking relative humidity.
Vivek,
Mass of the water vapor at the given condition to the ratio to the mass of the water vapor at the saturation condition, sir.
Again, you defined the same. You told me the same definition for percent humidity. Again, you are telling me same for the relative humidity.
Xerox machine में गड़बड़ हो glitch आ गया sir. Vivek, hello.
Yes, sir. Yes, sir. Yes, sir.
What is your full name?
Saragadam Vivek, sir.
Okay. So no confusion.
No, sir.
So listen carefully and answer.
Yes, sir.
Why you are giving wrong answer? In evaporators also you gave the wrong answers. All the answers were wrong. When was the last time you did study these subjects? How many years before?
Only 1 week back, sir, studied.
In 1 week you forgot everything.
After that, I started studying some other subjects, sir, thermodynamics and also some other.
Because of thermodynamics you forgot heat transfer and mass transfer.
No, sir.
Is it because you are nervous? Is it because you are giving interview for the first time? Or is it because there is some lack of preparation?
First time interview also, sir.
So you are not nervous, you are fully confident.
No, sir, I was nervous also, sir.
That's why you are mixing up. But you realize now that what is our point? Like I asked Raoult's law, I asked you to
Yes, sir.
define it, and it took me almost 5 minutes to explain what is the exact definition.
Yes, sir.
Now you know where you are lacking actually.
Defining the terms and
Exactly. You are not
explaining
defining
the
it properly.
exactly properly. I couldn't explain, sir.
I have not asked any difficult question.
Yes,
I'm
sir.
asking very, very simple question. And I'm
Yes, sir.
asking just definition, simple define. And there is actually the lacking happens. And we study big derivations. We are after the profiles. We are after the diagrams, graphs. But we forget to study the assumptions. We forget to study the definitions. We forget to study the meanings. We don't study. And that is why we always say that just stick to the basics.
Yes.
There is no benefit of listening to students that he wrote some feedback on Quora, he wrote some benefit of LinkedIn, these are the questions. No benefit at all. Only the basic knowledge of the subject will make you through.
Yes,
And the others' experiences won't much help in the BARC and interview or the
Yes.
NPCIL. Okay. So you are appearing for the NPCIL, na?
Yes, sir. NPCIL.
So what is the difference between PWR and BWR?
PWR, sir. What, sir?
What is the difference between PWR and BWR?
Pressurized water reaction.
Reactor.
Water reactor.
Water reactor. PWR, sir.
And BWR?
BWR, I don't know, sir.
Boiling water reactor.
What, sir?
Boiling water
Boiling.
reactor.
Yes, sir.
So you can tell me the difference between the two?
No, sir, I don't know, sir. I didn't
Okay.
study
You know the
about
working of pressurized water reactor?
No, sir.
Okay. So have you studied anything about the NPCIL industry working, how it works, how we produce the electricity, what is the purpose of the cooling rods or and all the things about the NPCIL? Have you studied?
Basically nuclear power plant layout.
यस सर लेआउट के बारे में पढ़ा लेकिन इन डेप्थ नहीं पढ़ा सर
इन डेप्थ नहीं
लेआउट के बारे में क्या
steps पता है वही सर पूछ रहे हैं
in the reactor the water is passed through it the uranium compound is reacted where chain reaction takes place and the neutrons that are removing continuously till the uranium fully consumed, up to which heat is released. This reaction is known as a nuclear fission reaction, sir. The during this process, heat is tremendous amount of heat is releasing, sir. This heat is absorbed by the water, sir. Water that is absorbed heat can convert into steam, sir. That steam is sent to the turbine where the energy is generated. The condensed steam is sent to the cooler and cooling tower where heat is absorbed. Again, it is sent to the pump, and then it is sent to the reactor, sir.
Tell me about the turbine.
Turbine
You are
which
saying that
generates
we
energy.
use heat to, we send heat to the turbine and produce electricity. How we do that? Thermal energy to electrical energy.
Thermal energy and electrical energy, sir.
How we are achieving it?
Don't know, sir.
Okay. Okay. Just one more question. What is the difference between the energy density if we produce electricity from the nuclear fuel versus if we produce the electricity from the coal?
Energy produced from the nuclear power is more, sir.
For a given amount of raw material.
Yes, sir. Yes, sir.
Okay, so if I take 1 kg of coal and 1 kg of nuclear fuel,
Yes, sir.
then the amount of energy produced in the nuclear fuel will be more.
Yes, sir.
So energy density of the electricity produced in the case of nuclear power plant is much, much higher than that of the coal power plant, thermal power plant.
Yes, sir.
Then why India is producing still almost 75 to 80% of its energy through coal and only, I think, less than 5% of energy through nuclear power?
Maybe it is
Maybe.
not as easy to control the heat released by the nuclear compared to the coal, sir.
But we have the technology. We have the PWRs with us.
Initially, we set up the coal, sir. Coal based technology, sir. Suddenly, we can't change, sir.
It's not sudden. If you know the history, even Homi Jahangir Baba is also tried for the nuclear power generation in the early 1950s. So India is trying to achieve that from the early 1950s. It's not sudden. It's almost 75 years for India to step into this field. It's not sudden. Okay. Ankur sir, any question or just should we wrap up?
No, sir, I just want to give a feedback to Vivek. Vivek, you have almost 9 days for your interview.
Yes,
almost a week, you can say effectively.
Yes,
and in this 1 week, try to read as much as you can as possible, especially your subjects which you have prepared. Finalize them, cover the basic concepts, fundamentals, and side by side, also watch the sessions we have conducted on YouTube, mock interview sessions with other candidates. It will help you to understand the type of questions and try to answer those questions by yourself. If you find any difficulty, so you can look for those answers.
Yes,
आपको काफी हेल्प मिलेगा, आइडिया लगेगा किस तरह से प्रिपेयर करना है. एंड मैंने कुछ अभी एनपीसीआईएल और बार्क के सेशंस भी लिए थे, इसमें कुछ टॉपिक्स डिस्कस किए हैं, जैसे आपका ये इवेपोरेटिव कूलिंग, वेट बल्ब टेम्परेचर, ह्यूमिडिफिकेशन से रिलेटेड जो टॉपिक है, उसका भी एक सेशन लिया था मैंने लास्ट मंथ के स्टार्ट में, जिसमें ये बेसिक टर्मिनोलॉजीज, उनसे रिलेटेड किस टाइप के क्वेश्चन पूछे जा सकते हैं, सारी चीजें डिस्कस की थी. वो आप देख लेना, हमारे चैनल पे मिल जाएगा, नहीं तो आप व्हाट्सएप कर देना, मैं आपको शेयर कर दूंगा लिंक.
थैंक यू.
ठीक है, और यही करो आप. बाकी एक चीज आपकी अच्छी है कि आपको क्लैरिटी नहीं है या कंफ्यूजन है या नर्वस एनर्जी है, जो भी, उसके बाद भी जो आंसर आपने दिए, वो आंसर आपने कॉन्फिडेंस के साथ दिए. मतलब अगर गलत भी बोलना हो तो कॉन्फिडेंस से गलत बोलना हो, मतलब समझ रहे हो? तो दिस इज वन गुड थिंग। मतलब
Yes.
प्रॉब्लम इज कि हमें वहां इंटरव्यू में गलत नहीं बोलना,
Yes, sir.
हमें सही बोलना है। तो इसलिए क्वेश्चन को अच्छे से सुनना है और फिर आंसर करना है, कुछ
Yes,
भी
sir.
नहीं बोलना, मतलब सिर्फ बोलने के लिए इंटरव्यू नहीं देना है।
Yes, sir.
वहां सोचो पूछा क्या है और उसके बाद क्यों पूछा है, मतलब इन्होंने ये क्वेश्चन क्यों पूछा होगा, क्या सोचकर पूछा होगा, ऐसा सोचो। थोड़ा 4-5 सेकंड 10 सेकंड का पॉज लो, फिर आंसर करो।
Yes,
इससे
sir.
आपको हेल्प मिलेगी और उन्हें भी फील होगा कि हाँ बच्चा सिंसियर है, सीरियस है एंड यस सच में कुछ करना चाहता है। और अगर कहीं कुछ आप स्टक होते हो, गलती करते हो, तो वहाँ वो हिंट देंगे। जैसे अंकुर सर ने भी राउट फ्लो वाले पार्ट में आपको हिंट देने का ट्राई किया,
Yes, sir.
तो वहाँ पे भी हिंट दिया जाएगा आपको, अगर आप कहीं जेन्युइनली स्टक हो गए तो। और उन्हें
Yes.
लगेगा कि शायद हिंट देने से ये आंसर कर पाए, ठीक है?
Yes, sir.
तो इसलिए सर ध्यान रखना कौन क्या बोल रहा है इस बातों पर भी। और
Yes.
यही मेरा फीडबैक कि सब कुछ सही है, बस थोड़ा अपनी नॉलेज और फंडामेंटल्स को स्ट्रॉन्ग करो। वो प्रॉब्लम जैसे मैंने आपसे जितने क्वेश्चन स्टार्टिंग में पूछे, ऑलमोस्ट सभी में कुछ ना कुछ गड़बड़ है, स्पेशली वो इवेपोरेटर्स वाला पार्ट, उसमें प्रेशर इफेक्ट्स के साथ डिक्रीज होता है, क्योंकि स्टीम फर्स्ट इफेक्ट में यूज होती है। स्टीम इज द सोर्स ऑफ एनर्जी। सेकेंड इफेक्ट में स्टीम नहीं भेजते, फर्स्ट इफेक्ट की वेपर्स जाती हैं, उनकी एनर्जी कंटेंट कम होगी स्टीम
Yes. Yes, sir.
कंपैरिजन में, तो टेम्परेचर भी कम होना चाहिए। अब सैचुरेशन टेम्परेचर तो कंसंट्रेशन के साथ इंक्रीज होता है, बॉइलिंग पॉइंट एलिवेशन, तो टेम्परेचर हम कम तो कर नहीं सकते खुद से, तो हम प्रेशर कम करते हैं, जिस वजह से सैचुरेशन टेम्परेचर कम आ जाता है।
Yes,
तो
sir.
वो प्रेशर कम होता जाता है, टेम्परेचर कम होता जाता है इफेक्ट्स। आपने बोला क्या था? उल्टा।
Sir, I studied correctly, but I.
फीडिंग मेथड्स 4 टाइप के होते हैं, फॉरवर्ड फीड, बैकवर्ड फीड, पैरेलल फीड एंड मिक्स्ड फीड। ये भी आपने पैरेलल को फॉरवर्ड और मिक्स को बैकवर्ड पता नहीं क्या बना दिया, ठीक है? तो इस चीज का ध्यान रखना, थोड़ा देखो ये सब चीजें।
Yes, sir. Yes, sir.
या ये फंडामेंटल्स में गलती नहीं करनी है, फंडामेंटल्स बिल्कुल क्लियर होना चाहिए। जो थोड़े एडवांस अच्छे क्वेश्चन है वहां अगर गलती हो जाए चलेगा, नहीं आता मना कर दो। और फंडामेंटल्स में अगर प्रॉब्लम होगी तो इसका मतलब फाउंडेशन ही वीक है ना, फिर बिल्डिंग कैसे बनाओगे? ठीक है, तो इसलिए 1 हफ्ता है आप पे, इससे अच्छे से काम करो और कर सकते हो, कोई ज्यादा बड़ा टास्क नहीं है,
Yes, sir.
ठीक है? दिस इज माय फीडबैक एंड ऑल द बेस्ट फॉर योर इंटरव्यू।
Thank you, sir.
जी सर। तो मैं तो ये बोलूंगा कि जैसा मैंने आपके भी बोला भी कि जितने भी दिन आपके पास है, इंस्टेड ऑफ डूइंग बिग थिंग्स, आई थिंक यू शुड फोकस ऑन द बेसिक्स,
Yes, sir.
है ना? एंड द बेस्ट वे टू प्रिपेयर इज टू वॉच ऑल द इंटरव्यू सेशंस.
Yes, sir.
We have taken so many interview sessions this year and last year, so all those interview sessions will help. Also, Ankush sir is taking any series, I think, sir, for in the interview. You took
या
one series.
जो लास्ट मंथ ली थी अब इस महीने उसमें फिर दोबारा स्टार्ट करेंगे।
So Ankush sir has taken one interview series. Manish sir also is has taken one interview series, and maybe Punya sir interview series also available. And mock interview sessions are available. So daily, I would say कि spend 3-4 hours, 5 hours for those interview series, है ना, mock interviews watching, through which you get to know कि actually how to answer.
Yes, sir.
The fault is not कि you don't have the knowledge or you cannot answer. You can answer, but the way you should answer through this mock interviews you can learn. Like
Yes,
if
sir.
somebody asks me what is the assumption of Fourier's law, है ना? Just give you an example. Let me ask you, what is the assumption of Fourier law? Just give me one assumption. You tell me for any assumption of Fourier's law. Tell me.
Constant temperature is maintained.
If temperature is constant, then how the heat transfer takes place?
Constant thermal conductivity. Temperatures on the surfaces are considered to be constant, sir.
Okay, let's say you said temperature on the surface is to be constant. Okay. So the temperature on both the surfaces must be constant, so
Yes.
that the heat transfer takes place is only one direction and there is no heat transfer taking place on the surface. There should be no gradient of temperature on the surface both the surface has to be isothermal. है ना? So if I explain the same thing in a little good way, better way, so then there will be no question from it. Otherwise, then the same assumption I can ask, why the temperature on both the surfaces are same? Then you will make it complex, will give some other answer. But the main idea is to study the heat transfer in one direction only. If the surface is having different temperatures, then heat transfer will take place by conduction from this point to that point, and from this point to that point also. Two-dimensional हो जाएगा, है ना? So that is the way.
Yes, sir.
That when I say something, I say something properly, है ना? So that the interviewer will ask another question now. Don't give them room to ask question after question on the same.
Yes, sir.
And that is the main idea. Okay. Rest everything is okay. You know the things, you have the knowledge. When we are giving the hints, you are picking it up. So that's
Yes.
good. You know it. You know the things. So you have the knowledge. I won't deny that. You studied. That that is look. ये हमें दिख रहा है that तुम पढ़कर आए हो. But the thing is कि आपको अब बताना कैसे, communicate कैसे करना, उस पे काम करना.
Yes, sir. Yes.